Going. Testing 1, 2, 3, 4. Solving logarithmic and exponential equations. So you already know most of the things you need to do to solve these. There's no real new properties. It's just using some of the properties of logarithms to solve these types of equations. So with this one, what you want to do is move this exponent up top. You remember that rule? So this becomes log base 5 of x to the second, right? Yeah. Can you shut up that light there? That, thanks. Equals log base 5 of 9, which must mean that what? X squared equals 9, yeah. And you might say x is plus or negative 3, but you can't take the log of a negative number.
Why can't you take the log of a negative number?
Why can't you take the log of a negative number? Because no matter, because when you're taking a log, you're finding an exponent, right? So you can have a negative exponent, but you can't have a negative log. If I take like 5 to the negative third power, right? That's always going to be a positive number, right? Even when I raise this to a positive number, negative number, the answer is always going to be, right?
I get you.
So that's 1 over 5 to the third, right? So if this is y, right, that's good. Anyway, so that's how you solve that one. That's pretty easy, right?
Yeah.
So with this one, this is a little trickier. What you want to do is use the product. The sum of the logs is equal to the log of the product. So you can rewrite this as log base 4 of x plus 3 times 2 minus x equals 1. And this is kind of a funky problem. Then what you do is you get rid of the logarithm. And the way I can get rid of the logarithm is rewriting this as 4 to the first power equals this, right? So you get 4 to the 1 equals x plus 3 times 2 minus x. And then you multiply stuff together. What's 4 to the 1? 4 equals, and then you have to try to FOIL this, okay? And so what would I get? I get 2x first. Outer, yeah, I'd probably do that. First is this, outer is minus x squared. Inner is 6. And last is minus 3x. And then what I want to do is get everything on one side and write a quadratic. So that becomes, I'm going to bring everything over here to make my x squared. Did I do that? Let's leave everything over here. So I get negative x squared, 2x minus 3x minus x, and 6, I'm going to bring this 4 over here, plus 2 equals 0. Keep going. Then what I would do is multiply everything through by -1 so that I can factor it easier. So that gives you x squared plus x minus 2 equals 0. And then what do? And you factor it. X plus 2 times x minus 1 equals 0. So either x equals -2 or x equals 1. And can you have a negative in here? You would check it, right? And -2 does work because it doesn't make any of these negative. And 1 works as well. So both of those are okay answers.
What happened to 4?
4, I brought it over to this side.
Yeah, but then it just disappeared.
What?
Yeah.
Because I subtracted 4 from both sides. I said 6 minus 4 makes 2. I'm sorry. I skipped a step. Minus 4, right? Why did I get rid of the 4? Because I want to get everything on one side and make it equal 0 so that I can factor it. All right? We're good with that?
How'd you get rid of the logarithm?
How did I get How did I get rid of the logarithm? I rewrote this as an exponential equation. So this to the 1 equals this, right?
So if it was equal to 0, would you say 4 squared? that what it is?
If this were 2, then I'd say 4 squared equals this.
Okay, so that's where that was.
Yeah, the 1 comes from, this is 4 to the 1 equals this. All right. Letter C here is kind of tricky. So, and all of these are kind of like what I call contrived problems, meaning I doubt you'd see them in real life, but they're kind of ones to practice your algebra skills and properties of logarithms and stuff like that. So, anyone have any suggestions on this one? Anyone have any ideas? You would? What?
Oh,
Could you, I mean, put the negative 2x on the other side and do the square root of x? Like,
what is?
Really? But how can I rewrite 4? 2 to the 2 raised to the x, okay? Minus 2 to the x.
What did I do to the 2x?
Yes, which is, yes, what Cameron said. 2 to the 2x minus 2x minus 12 equals 0. So this is what I'm going to do, okay? I'm going to let, one way to think about this, you could do, kind of do a substitution. Let y equal 2 to the x. Then y squared would be what? 2 to the 2x. Do you guys see that? Because if I square this, you multiply the exponents.
Yeah.
So this is kind of a tricky, weird kind of problem. Okay, so you let y be 2 to the x, or you can just do this without doing the substitution, but I think it's kind of better to do like a substitution like this. Then you can rewrite this as a quadratic equation. Y squared minus y minus 12 equals 0, which factors nicely. See? And you get y minus 4, y plus 3 equals 0. So either y equals 4 or y equals negative 3. And then you have to come back over here and substitute that. Okay? So in this case, you say 4 equals 2 to the x, or, right? 4 equals 2, or 4, or negative 3 equals 2 to the x. Well, so what's x got to be? 2 to what power gives you 4? 2. X equals 2. And over here, I remember I can't raise x 2 to any power to give me a negative number. So this one you throw away. No solution to this. So this is your only answer. That's kind of a tricky kind of contrived problem. They have it in there, so
Try it.
that's good. Isn't that fun?
No.
I like them. Okay. The next one is pretty straightforward. D. So all you do with this is you just rewrite this as who knows what to do with that? Huh? Put 5 on the other side? No. What you want to do, I would just, you could rewrite this in logarithmic form or take the log of both sides. So when you take the log of both sides, you get, I would just take the natural log because it's shorter. It doesn't matter really which one you use.
Is the only reason you're doing that just because like it's less letters to write?
Yes.
Okay.
Okay, the only reason I'm doing that is because it's less letters to write. Okay? And then I'm going to bring my x in front, which you're allowed to do. So I get x natural log of 2 equals natural log of 5. And that gives me x equals natural log of 5 divided by natural log of 2. And if you want a decimal answer, you can plug that into your calculator, but that's good enough. If they say leave your answer in terms of a logarithm, that's what they mean. You know, you kind of have one sort of like that.
You also leave that in the difference of...
No, because this is not a different, because it's only a difference if it's log of 5 divided by 2. Log of the whole thing. right?
Yeah.
So it's not a difference. Okay, good with that one?
Yeah.
Next. Two more examples. Oh no, three more examples and we're done. Okay, so this one is kind of similar to that last one. The only difference is that and these come up a lot, actually, knowing how to solve this type of problem comes up a lot in real life applications, like in interest rates and stuff like that. So this is kind of the basis for solving that kind of problem. And so what you do is you first divide by 8 to get the 3 to the x by itself. And then you have 3 to the x equals 5 over 8. And then you natural log both sides. Okay? So you get x. So I'm not going to rewrite the whole thing. I can bring the exponent down this. Natural log of 3. I'm kind of skipping a step here. Equals natural log of 5/8. Yes?
Yeah.
Okay. And this, what Cameron said before, you can write this one as a difference. You don't have to, but you can write this as natural log of 5 minus natural log of 8. And then, so x, all you have to do is divide both sides by the natural log of 3. And you get that x is equal to natural log of 5 minus natural log of 8 over natural log of 3. Yes, ma'am?
So can you just leave it as natural log of 5/8 over natural log of
Yeah,
3?
you could too. Okay? And if they ask you for a decimal answer, then you plug that in. And again, these could also be regular base 10 log. It doesn't matter. The answer will still be exactly the same. All right? How many more? 2 more. Look, this is fast.
Yeah.
Yay. So, this one's hard.
Do we have the time for this?
Do we have the time for this? This one gives me a headache. Okay? It might give you a little bit of a headache, but it'll be okay. So with this one, they say solve it. What you want to do is first I would take the natural, it's just a lot of steps. X minus 2 times the natural log of 5 equals 3x plus 2 times what? Natural log of 3. But then what you got to do, you got to get x by itself, right? Which is kind of an involved process. What you have to do is distribute first. So when I distribute this through, I get x natural log of 5 minus 2 natural log of 5. See, I'm using the distributive property. This times this and this times this equals 3x natural log of 3 plus 2 natural log of 3. And then, kind of what I did before, I want to get when we're solving those, when we're doing the inverse things, where I have to find the inverse of a rational function, I want to get all the x's, anything that has an x on one side and anything that doesn't have an x on the other side. So now I have, when I do that, I get x natural log of 5 minus 3x natural log of 3 equals 2 natural log of 3, and I'm going to bring this over to this side, plus 2 natural log of 5. Now what can I do? What can I take out of both of these? X. So now I can take an x out, and I get x times the natural log of 5 minus 3 natural log of 3 equals 2 natural log of 3 plus 2 natural log of 5. And then I divide by this. So I get x equals this messy thing, 2 natural log of 3 plus 2 natural log of 5 over natural log of 5 minus 3 natural log of 3. And if you want a little bit nicer answer, you could write this as a natural log of 3 squared, which is what? 9, plus the natural log of 5 squared, which is 25, over the natural log of 5 minus the natural log of 27. I'm not done yet.
I don't like this.
27, which is equal to, see, this is a sum, right? So I can rewrite this, and this is a difference. So I can rewrite this as a natural log of 9 times 25, which is 225, over the natural log of 5 27ths. Whoa. Because this is a difference, and this would be your best answer. But if you get to here, that's pretty good. That's pretty hard, isn't it?
Wait, how'd you jump from there to the next one?
How'd I go from here to here?
Yeah.
Because natural log of 3 is the same as natural log of 3 to the 2. 2 natural log of 3, I can bring this exponent up top, right? And this exponent I can bring up top. So I'm kind of going reverse of that rolling the log thing I gave you. And the very last thing, just let me do the very last one, okay, is this. Oh, and there's your homework on the bottom of the page. And the very last thing, solve using a graphing calculator. I'm not actually going to solve it, but if I were to do that, whoops, you graph y equals x plus e to x, which is kind of going to look, what is that going to look like? I think it's going to look like a steep exponential function. So if this is y equals x plus e to x, and then you graph y equals 2, right? Y equals 2. I think these cross over here. Never mind. And you graph y equals 2, and you see where those two things cross. And I think you will find that those two things, do they cross at 0? I'm not sure where they cross. But you find out where they intersect. Okay? And your homework is right down here. See it? Make it bigger. I can make it bigger. I thought that was pretty good class teaching. And remember, you heard it here on K-Leader Math. K-Leader Math Channel Roller Derby. The end.